And this is our first QSR event for interaction between students and their industry. We're so glad to have three experts and one is coming on the way. And my name is Peter Liu. I'm a chair of the membership growth for the QSR community. QSR stands for Quality, Statistics, and Reliability. It's a session in informs, and here we really want to connect people who are interested in statistics, reliability, operations research, and artificial intelligence. We want to make collaborations between the industry and academia, and hopefully we can all learn something from this kind of communication. And if you haven't been the members for the QSR, you're welcome to join the QSR, and we'll have some relevant event in the future. And once again, thank you for coming, and I hope you enjoy the session and talk with the experts here and get what you want. Thank you so much. Alan, back to you.
All right, everyone. So my name is Alan Vasquez. I'm from Tecnológico de Monterrey in Mexico. So thank you for connecting. So we're very pleased to host this event. And we have three amazing speakers. We're working on getting one of them because there are some technical issues. But for the moment, we are going to start. So the plan is that we would like you to interact with our speakers either through the chat or by raising your hands after all of them present. So please, we would like this to be like the particular characteristic of this session, more like an interaction between speakers. Any questions that you might have, any doubts, or how to strengthen your application, or what is the path that you need to follow in order to land a job in industry. So all of those questions plus other ones that you can have, please do not hesitate to ask them through the chat or by raising your hands. So what we're going to do is to start with the first expert in industry. We have three of them. First of all, Fabio, Surirat, and Xiang. So we're going to start with Fabio. So Fabio, we can just give your presentation and share your experience with us.
All right, thank you. First, thanks for the informs for letting me do that. It's a pleasure. Let me see if I can get my screen here. Oh, it was always all right. So you should be seeing a slide very soon. If you can confirm, Alan, you can see the slide deck.
I can see your screen, but not the slide deck. I just saw it a moment ago, but I cannot see it now.
Okay, just a sec, I'll fix it. Now we should be able to see it. Correct?
Yes.
Okay, let me see if I can put on the slide. All right. Thanks everybody for being here and for the informs for inviting me for that. My name is Fabio Taviano. I work for Dow Chemicals, whose headquarters is in Midland, Michigan. I'm actually based in Texas, and that's my story here. I'm a statistician, who's been around quite a bit. Yeah, been in Dow 21 years. Last 10 years based near Houston, Texas. But I've lived in other 4 countries for quite a bit. I'm an engineer by training. I started Dow as an engineer, and I would do technical sales. And I've been around the globe a lot, and that in a way helped me grow as a statistician, because later in my career, by my mid-30s, I realized that all these interactions I had with customers around the globe, they were full of noise, people discussing problems that don't exist, and those that exist we don't discuss. So at the end of the day, I decided I need to get this straight, and I decided to take a master in statistics, and my story as a statistician began there. And as a de facto statistician, I've been as such since 2014. And I can tell you that having a multidisciplinary background does help in this specific job at Dow. In terms of stats at Dow, R&D statistics is what I do, is a function inside a bigger function called core R&D. And core R&D is just, long story short, is a consultancy function that offers services to the various Dow businesses in terms of material science, chemistry, analytics. So basically all the various business that you have in Dow, they don't need to hire a statistician because they can pull me into their projects. So they are my internal clients. Here is a little bit of a joke, just to introduce the topic I'll talk about later. Data scientist and statistician walked into the bar and the waiter says table for one, right? Well, that's because, I start the story here. In R&D, specifically where I work, the most important data is the data you don't have yet. Like R&D is far more about exploration than it is about exploitation. So in terms of statistics, statisticians, they design data on purpose, and the data has to be optimal for the analysis that follow. It's basically retail scale. You need to invest money on generating this data, and most of the data, if not all, nearly all, are tabular data. And we do have a lot of work and research on optimal designs, because we always need to find a trade-off between all the cost for generating this specific set of data and the risk of having a bad decision because you didn't have enough data or the data was not designed appropriately. And we also have data scientists in R&D, but it's quite a little bit of a different job, even though table for one, right? Because they feed on repository data, which is almost always not generated on purpose. And the intent with that is to gain perspectives, to understand stuff that would cost just too much for the company and would be impossible if you try to design for that. And obviously the data tend to be more like whole scale, and you have a diverse variety of types. It's not only tubular, it can be image, and can be other stuff as well. In terms of my job, I divide it here into two types of jobs that I do. One is lab-based product development. And here is the first part of when you do lab-based product development, the project starts with problem definition. Very often, even though I'm working with internal clients, not external, but they also have the problem of defining their own problem. Dow operate mostly in markets where you don't need to, go to FDA to prove efficacy. So there's no protocol for you to show that. So it depends a lot on your creativity and obviously stats knowledge to devise new protocols. And communication is very important, because if I have to tell you that the most difficult part of a project is not even on the stats part, is actually on defining what the problem is, because if you get that wrong, everything else that follows is wrong, which is kind of obvious, right? The other thing which I think is very underrated in the job of statistician work in R&D is measurement system analysis. As opposed to data scientists, where they just grab data from somewhere. Here, when we generate the data, we have the chance to actually estimate the irreducible error, right? And that's how we do it. And that demands that we design experiments for exclusively estimating the irreducible error. And as we use lab equipment, many times, a statistician, you need to go a little bit away from your area of expertise, because you need to understand how your client is measuring stuff, right? You need to understand how the machine, how the experiment is done, and understand with your own eyes. The eyes of a statistician can see sorts of variation in many places that typically an engineer cannot. Okay? So you will need to even observe it in loco or learn about how the measurement is taken. In Dow, we have high throughput equipment. For those that don't know what high throughput is basically we do chemistry, but instead of seeing a person in the lab on the bench top feeding, adding chemicals to a beaker, actually it's a robot doing that. And because of that, we can do, the scale is much larger. And that, together with all the development of machine learning recently, provided us a way to step into new territory, which is designing for machine learning, which is only possible when you have large-scale experimentation. And that opens up the possibility for us to do publications and even patents and things of that sort. Going to conference like this one. The other part of the job is field real-world trials. You know, Dow produces a lot of chemicals that people use in your household. You probably have a Dow chemical today, and you don't know. But these chemicals can go into the air and travel very far. So the company is also responsible to understand, to the point that it wants to understand how far chemicals travel and measure traces of chemicals around the world. And for that, you also need to design data to be able to estimate these correctly. The other thing is, there is a business in Dow which deals with oil and gas, and we sell something called chemical stimulation product, which is kind of a rival of fracking. For those in oil and gas, do you understand what I'm saying? And whenever we, for example, develop a new chemical stimulation process, we need to go to our customers and measure the efficacy of that product in the field. And it's funny because it's really like a clinical trial, and every well, it's a patient, right? So you get to think about that. That's exactly what it is. So you're having a clinical trial, except instead of a person, you have an oil well, right? In a big field comprising many, many wells. The other thing, crop science, even though Dow doesn't do seeds and pesticides yet, not anymore. We do make products that help, for example, in this case, reduce the consumption of water in crops. And if you don't know, most of the water consumption in the world comes from agriculture. Last time I checked, it's about 80%. So anything you can do to reduce water consumption in agriculture helps. And whenever Dow develops this thing called soil amendment, which means the product you put in the water, so you need less water, we need to also go to the field and test that and have a typical agricultural trial. All that I'm saying here, there's no established protocol for that. There is no FDA, USDA, nothing. There is a toxicology regulation, obviously, but not for efficacy. So you always need to invent a way on how you're going to measure whether things work or not. And initiative is needed. It's not a type of job that you're going to get there and you know by heart exactly what people will ask you, and people will come to you and ask you specifically to do certain things. You need to find out what to do. Now moving more towards how to better prepare for a job in terms of resumes and interview. First thing I want to say is once you get your diploma, great. That only will help you get an interview, because a lot of other people also have a diploma, right? So what really makes you stand out are publications, participation in conferences, or professional associations like Informs, internship, job experience, TA experience. They all provide context for you later to have your interview, and I'll talk about that in a minute. So that matters a lot. For most R&D jobs in Dow, a PhD is required, but not for all jobs in Dow, and not for all jobs in that, just most, okay? But for statisticians, you may hold a PhD in another STEM field. You can be an engineer, they have an engineering PhD. But if you have a master in stats, that will work, because, dual domain training, it's really in demand these days. In Dow, we do all job interviews will be behavior-based, and you get those type of questions. Tell me about a time when this and that happened to you. And that's meant to, see how you handle difficult behavior situations in the past. I still see some candidates struggling a lot with this question, as if they get even surprised we are asking them. So I would tell you, prepare for them. They're always the same. You can go to the web and find about behavior interviews. The questions are always very similar. The topics are like half a dozen, if not less. And also remember that you're just trying to find if you're a good fit for the company, and you as well as trying to find if the company is good for you. So just be yourself. Other thing I want to tell you about interview is very often we ask, why did you choose stats? I'm talking about stats because I'm presuming most of you are related to statistics, but if you're an engineer, they'll ask you why you chose that kind of training. And sometimes you get an answer like, well, Stats about math. I know how to communicate better with math than with words. And that's not going to work very well, right? Because as you can see, communication is really necessary here for you to do your job later. So think about that. We really want somebody that chose stats for what stats can do, not because it was easy to get away with something. In terms of opportunities, I want to start first with this BEST symposium, which we call it Building Engineering and Science Talent Symposium. It is an industrial research career conference. It's aimed at applicants for underrepresented minority groups in the US. And the requirement for you to participate is that you're going to have a doctorate degree by November 2025. And you can apply. Here's the QR code. Here I have the link. I hope, Alan, later we can, pass it on to people here. I will give you the material. You can click in here. But if you want now, right now, you can go on the QR code here. If you apply by April 30, you're going to have a very short interview. And once you're selected, Dow will sponsor a travel to Midland, where this symposium is going to happen. And the objective here is really make you learn about Dow and what a career in the industry looks like. Then the other opportunity I can tell you up front is what we call a DICE program, Advanced Digital Internships for Scientists and Engineers. It's a digital summer internship program. The program for this year is already done because we selected everybody last year, but for next year, 2025, the program is going to be launched sometime in the fall or late summer. And if you go on this QR code here, it will help you demonstrate that you have interest in that. Then you're gonna, because if you go right now on the web, there's nothing about our 2025 program. But if you want to be advised and get some notification that the program it's open and you can apply for that, that's what this QR code is for. ADICE targets graduate students, yes, in STEM fields, with obviously experience in machine learning or computer science, but as well as statistics and data science students that are not engineers, right? So you don't need to have that dual training. And we are welcoming a lot if you're a statistician and you apply for that. In general, I also am putting here some links to internships at Dow, and you can find that also on LinkedIn. And even if you don't find anything that is of your interest, you can still sign up for the talent community, which will again send you a notification whenever something that is aligned to your profile shows up, and then you know that. So I'm done here. I don't know if I went over the time, Alan. You let me know.
Yeah, I think it's a good point to give the floor to another speaker. Thank you, Fabio, for sharing this. So Surirat, are you with us through the phone?
Yes. I'm sorry, I have issue logging. Getting in the Zoom. I don't know why. Typically not the issue, but yeah. I'm so sorry.
No problem.
Thank you for inviting me.
Yeah, we also apologize for the inconveniences, and we thank you for your patience. So if we can continue with you, if you can introduce yourself and share your experiences to all the attendees, all the students that we have now. So yeah, if you can start with your 15-minute presentation or talk.
Yeah. So I will just go through the topic that suggested for me to talk about, like my experience working in the industry, and also how the student could prepare to get into industry job and what expect from the student. And if anyone has questions, just ask me. And the important thing to note here is this is my experience and it's not applied to everyone. And you may know or not know, so I'm a staff AI/ML scientist in Siemens Healthineers. So my work focuses on healthcare technologies. So it also means that whatever I experience is not applied to other fields like financial technologies or entertainment technology. That is different field. So whatever I say, it's based on my experience working in my field. so it's still pretty narrow. Just so that you don't assume that whatever I say is true for everything. So working in the industry for me is actually quite rewarding because it's in healthcare technology and challenging at the same time. The good thing is, unlike in academia, the focus is on the work that can be used in real clinical application or workflow. In academia, you can spend time thinking about like innovation or a new way to solve the problem that may not necessarily usable or applicable to whatever out there in clinic right away. But in industry, especially for healthcare technologies, you do have the freedom to come up with a new innovation and new method. However, the main focus would be in order to help improve whatever problem that hospital and doctor have. So the challenge here is that whatever we come up with, it has to be helpful and it cannot harm patient. So any issue that could come from the algorithm hallucination or any unreliability things is not acceptable. So but it's rewarding when you can solve problem and help bring healthcare to a better precision and safety for the patient. So there's a challenging and rewarding at the same time. Now, how could you get into the position in medical technologies in, say, big company? So there's a lot of startup nowadays as well. So I don't have experience joining startup companies, so I don't know what would be the requirement for you to pass through the interview process. But for big healthcare technology company, one important thing before you even get to interview is you have to pass through the CV filtering process, right? Your resume and stuff. So you have to stand out. What I mean by stand out is it's different. It depends. So if you won some awards or you give a talk in the very prestigious conference, you have a bunch of publications, you get some grant, something that makes you different than other, outstanding in terms of if we have you, we're gonna have a lot of improvement, have a lot of good things come out of the company because your knowledge and your experience is far above other candidates. So you have to stand out for us to pick you for an interview. And after you pass the interview process, that is you get the job, right? But the first thing is even, I think to me, is quite hard given nowadays there's a lot of candidates. So there's a lot of CV to look through. So your CV have to stand out. And after that, I think it is not as difficult as the first step of achieving something and putting your CV so that it makes you stand out compared to the others. So what expect from the job if you join the company in healthcare technologies? The healthcare technologies, what I mean by healthcare technology is not pharmaceutical technology. Pharmaceutical technology have a different expectation from you. And I don't know that because I'm not in pharmaceutical technologies. I'm in healthcare, like anything that involves hospital, not medicine per se. As I said, whatever we do, it means patient life. So we can enjoy the high technology, the beautiful mathematical computation and derivation, but in the end, if it does not help patient, it doesn't mean much. And so the only important thing that we expect from everyone working together in the company is we are honest about what we do. We transparent about everything we do. We have the same goal of helping other people. I mean other people is mostly a patient, and that pretty much it. Yes. So if anyone had any question, feel free to ask.
All right, Surita, thank you for sharing your experiences, your knowledge. So I suggest that we move on to the last speaker, Xiang, and then we can have time for questions. So please, all your questions, put them on the chat and we will read them. Or if you want to wait until the end and raise your hand and ask something, you can also do that. So Xiang, let's go with you, please.
Thank you, Alan. Thanks for inviting me. So my background is a little bit different from the first two speakers. I did not start my career in industry. I actually started my career in academia, and I spent 10 years in academia. I started with after I got my PhD, I started with assistant professor position at City University of Hong Kong, and then about 4.5 years after that, I moved to University of Arizona. And then I spent, I guess, maybe another 4 or 5 years there. I started with assistant professor, and then I got promoted to associate professor. So this is the first part of my journey in my career. And then during COVID time, I started to look for other opportunities, and about 2.5 years ago, I decided to move to California, and then with my wife. So now I'm working as an applied research scientist at Meta Platforms, formerly known as the Facebook. So maybe I can offer some of my own experience and opinions by comparing with working in academia and working in industry, how they are different. But I'll leave most of these to the questions session. Now I'm going to introduce a little bit of my current work, because I've only spent like no more than 3 years in my current role, so my experience is limited. The org that I'm belonging to is called enterprise engineering. And what we do is we leverage machine learning optimization, statistical and simulation methods to solve enterprise operational problems. Specifically, for the area that I'm focusing on in the recent years is supply chain and data center operations. So for data center operations, like big IT tech companies like Meta, we have I think we have about no more than somewhere between 20 to 25 data centers throughout the world at different geographic locations, and then the operations maintenance of these data centers, actually it's a huge amount of work. And we need to make sure the data centers are operating as expected, and they are basically our the machines that powers all of our softwares, all of our services to our customers. So they need to be very reliable, and we constantly improving these servers to when there are new. For example, when there are new generations of servers and new generations of GPUs that are available to the market, we need to upgrade them. So there's actually a lot of work to do over there. And the other part is the supply chain. Some of you might wonder what supply chain for Facebook, for Meta. That was actually also my question before I joined. But it turns out actually there are a lot of supply chain problems, even just for the data center itself. Okay, we need to start build the data center. We need to buy the server racks, and we need to deploy them. We need to and there's a lot of optimization, logistics problems, planning problems within this. Another part of the supply chain problems is I don't know how many of you knows actually Meta has some hardware like the VR devices and smart glasses. So we manufacture those. And of course they are actually outsourced to like contract manufacturers. But we need to make sure that they're manufactured according to our standard. So there's actually manufacturing quality problems and production planning problems, and then how to ship those finished products to our warehouses. We also have warehouses throughout the different continents of the world. So where to ship them and how to make how to predict the demand at different warehouses. It's basically at different regions. For example, we have like I think 2 or 3 warehouses in US, and we need to decide when and where to ship and how to ship. So a lot of supply chain problems, logistics problems, simulation, the tools that or the type of problems that we are all we mostly facing are like forecasting problems. Like you need to forecast the demand, right? So either the demand of like how many VR devices or smart glasses that we can sell in the next month, next week, or forecasting problems like for data center operations, like we need to maintain the servers, and there's a lot of like servers they can go down sometimes because of some bad parts, some issues with them. So we need to maintenance, we need to repair, and we need to have new parts ready, spare parts always ready at close to our data center, so that when some parts go back, we can swap them with the new parts. So forecasting, we also need to forecast the demand for those spare parts as well. So a big chunk of our work focus is on forecasting, use whatever methods, honestly. And classification and regression, like a more traditional machine learning type of problems, and also optimization. Optimization like for scheduling problems, for logistic problems, and simulation as well. So this is a type of problem and the area that I've been working in the last 2 or 3 years. The big difference that I find comparing working at academia and industry is that, of course, most of the things like projects move much faster, much faster than when I worked at academia. Like at academia, we can plan, let's say, for a project for sometimes we plan, let's say, for an ASF project, it's 3 years. Okay. But 3 years in industry, at least based on my experience, I think this is probably a little bit different, because like these IT tech companies, they move really fast. They move really fast. Like for example, when there's a new technology emerging, like for generative AI, then we need to quickly switch to these new emerging technologies. And then we need to build our new projects based on these new methods you need to learn and you need to deploy. So a lot of our projects are planned based on like quarter, half a year. So moved much faster. And I really had, I had to spend some hard time adjusting myself to that. So for students who used to the academia environment and want to move to industry, I think this is the first thing that you need to keep in mind. And also always keep your curiosity open to new technologies, right? Just like the generative AI thing. If there's new emerging technology out there, then and if you feel that's possibly can benefit your work, you should actually start to learn as soon as possible, and find ways if they can benefit your projects. Another thing that I've learned the difference between academia and the industry is that like there are a lot of cross-functional collaborations. Like we have many functional departments. Like we have data scientists, we have data engineers, we have research scientists, we have engineers, software engineers, and we have product managers, and we have product designers and user experience researchers. And for a project, typically we used to work, not necessarily all of them, but a lot of them. So the communication I find has become much more important while working at the industry comparing with academia. I'm not saying communication is not important in academia, but I feel it's much more important, and it's much more intensive working at industry. And I think also another thing that I feel is like while working at academia, most of the other people that you collaborating with on projects, in a lot of cases, we understand each other relatively well. Basically, we speak the same language, we have the same skill set. Okay, when I say machine learning, oh, okay, my collaborator immediately knows what I'm talking about for a lot of cases. But when we have a lot of cross-functional teams, some of the people, they come from business background, they come from other area background, sometimes they really don't know what you're talking about. So I think there's also you need to be aware of that. And in particular, I think for students who are close to graduation, you need to find ways to, I think, practice your collaboration skills, team skills with other people. Third thing, maybe the last thing that I want to mention about the difference in academia and industry is, so in industry, we often want to, let's say, develop some really good methods. Let's say we want to improve, for example, the accuracy from 90% to 95%, 93%. And we think it's good. This is good. Maybe this is good research work. But for my experience, a lot of projects that we worked on, we are really focusing on improving maybe from the current 20-30% to 80-90%, which is the biggest chunk of the improvement that really solves the largest portion of the business problem. And the remaining piece, maybe just 10% of room for improvement. Usually we don't spend a lot of time working on that. So that means some of the methods that you use, we are open to any methods that you can leverage. But sometimes we solve the problem by just implementing some simple methods, like linear optimization, linear regression, or random forest, things like that. Okay. So I mean, these are the three aspects I find that are mostly different while working or receiving your education in academia, doing research in academia, and working in industry. Yeah, that's all I want to say. Thank you.
All right. Thanks, Shang. Thank you very much for sharing. So then part of the session, as I mentioned at the beginning, is that we interact with each other. So if you have a question to one of our speakers, please feel free. So we have a very rich environment with different companies, different advice, different visions. So I really encourage you to take this opportunity. There is no right or wrong question. Just simply ask whatever you always wanted to ask to somebody who is working in the industry. So yeah, we can start with the first question. Yes, go ahead.
Hello, everyone. I'm Setare from University at Buffalo. I'm currently a third-year PhD candidate at Industrial and Systems Engineering. As the president of Informs chapter at UB, I wanted to thank you all for having this panel. I know how much planning goes to each of these events, so thank you so much. My question goes to Dr. Zhou. I wanted to know, like, if he can give us some tips on how to prepare for some technical questions for interviews. Thank you.
Okay. Yeah, that's the part that I missed in my in my introduction. That's a good question. And I think, I can only speak for based on my own experience. So my own experience is limited to these tech companies like Google, Meta, Amazon, Apple. So I think what you need to do is you really need to understand the interview process, the problems beforehand in advance. Make sure you really understand what problems that you will be asked about. I think earlier someone mentioned behavioral questions. Sometimes I heard some candidates, they struck by surprise. They didn't know that there are behavioral questions. And then they just answer it based on whatever they have off the top of their head. So the result obviously won't be good. Make sure that you reach out. So to get that, one thing is that you can leverage some of maybe the discussion forums on the internet, but the other part is reach out to your someone graduated before you and who's maybe working in the same or similar type of companies. Ask them like what type of interview questions that you should be expecting, and you should really spend a significant amount of time preparing those questions, because most of those questions are pretty, I would say, quantitative. Okay, if you prepare well, you can answer well. If you don't prepare, there's no way you can answer them well. Believe me, like those coding questions. Well, I've also been tested with those coding questions. Like you really need to familiar with their style of coding and what are they expected. For example, the coding, they asked me to code a dynamic programming problem. If you don't prepare well beforehand, there's no way you can do it. And there are some like other, of course, I think your training at school also helps with some of those background problems. Maybe, for example, they will ask you like tell me about how random forest works, for example, just for example. Tell me about the experimental design and what they can achieve. Usually we do A/B test, but it's really the same thing. Not very significant, but significant overlap over there. Yes, so my recommendation to you is really understand no surprise. You should have zero surprise during the interview process. Okay, and reach out to the people you know that are working at those companies. Ask them to give you referrals. Referrals, I think in a lot of cases, it might help a lot. In some cases, it might not. But somehow I feel most of the candidates, they have some kind of referrals. So if you don't, then that's a disadvantage for you.
All right. So thanks for the question. Please, anyone else would like to ask something? And for the speakers, if you can, I kindly request to be short in your answers, concise, because we want to answer as many questions as we can. So Chris, please go ahead.
Hi, thank you. Thank you for arranging today's event. I know it takes a lot of hard work for arranging such a good event and productive one. So my question is for today's esteemed guest. So being an interviewer, so from the interviewer point of view, what are the qualities, what are the 2 or 3 qualities you'd like to see in an interviewee? And what are the things that would upset you the most? And so good and bad qualities from your point of view in an interview. Thank you.
So Fabio, can you help us with that?
Yes.
I think your question, you asked 2 things, but there are, for me, if you're saying the best thing I want to see is that I understand what they speak. Okay, that's very important, that they speak clearly and I don't have to guess what they're saying. And on the other hand, if you ask me what is that bothers me the most, is when I cannot understand what they're saying. It does happen, right? Sometimes, I mean, many of us here, if not all, we don't have English as a native language, right? And it's very hard to when it's very hard to understand. We try to, you know, ask a second question to clarify the first, but you know, things tend not to get that clear. And what can I say about the thing that upsets me the most is the opposite, is exactly not being able to understand what the person actually is saying. And the other thing, just if I can tell you, is, you know, we are talking about behavioral questions here. There's 2 opposite. One is when the person is surprised by the question, and I echo the answer we heard before, that if you get surprised by that, probably you're not going to give a good answer. But then there is the other opposite, when we see that the answer is rehearsed and some kind of not you, right? That's that too. So we can pick those kind of things.
Thank you. Thank you so much.
Right, so let's go ahead with Chris M.
Hi, thank you all for hosting this and for speaking with us. My questions for each of the speakers. I was wondering what each of you are seeing as emerging themes or technologies in your various lines of work.
So if we can ask Surirat to answer this question, so we can have a nice spread of answers from different points of view.
In healthcare technology, you probably see that it's quite similar to whatever other field is. Because nowadays everyone is go for like you know, large language model as well as image synthesis within the same multi-modalities deep learning model, where you can have the model interpret image or do something with image and language at the same time. So that is what driving the trend in healthcare. However, if you talk about a real healthcare that is applicable, that is not the thing. That is the thing that you know, set the hype in the market. But the thing that really useful for the clinical partner, they are more of they're different thing. And I don't think I should get into detail because we should move forward. But basically, what I say is, whatever the trend for publics is also the same in healthcare, because that make the market grow. However, the real thing that we produce as a product for the hospital, they are somewhat different. Yeah. I think that's my answer.
So Angie, you can go ahead and ask your question.
Okay, thank you for hosting the event, and thanks for all the speakers sharing the useful information. I'm a PhD student from Industrial System Engineering at Auburn University. So I have one question, maybe goes for Dr. Zhou. So we know we propose there's some collaborations between the academia and the industries, right? But as you mentioned, the industries and academia, when we're trying to conduct the project, our purpose or goal probably a little bit different, because industries would like to move faster to implement algorithm very fast. But considering the academia purpose, we probably will like to develop methodology more deeper or theoretical. So how can we negotiate this kind of situation if we have a cooperation between the academia and the industry? Thank you.
Well, I think like joint projects between academia and companies, they benefit both, and basically people on both sides take what they want. Usually, so I've been on both sides. On the university side, you would want to real world problems. You would want to get data sets. You will want to get background, business background problems. That's the motivating problems, right? You can always get that. You can always get the data set that you want, and then you can build your fancy algorithms. You can always do that and publish papers and maybe looking for future working towards future projects. On the company side, we just get like there might be two purposes. One might be we see if there's something potential to develop like advanced method. Okay, and another one is maybe we want something that is immediately implementable and that can solve some business problems. But either case, I think both sides get what they want. It's just win-win for both sides.
Okay. Thank you for your information. Thank you.
All right, so I think we are right on time to move on to the closing remarks. So here we have the president of the Quality, Reliability, and Statistics section, Gisha. So Gisha, if you would like to give the closing remarks for this great session.
Well, thank you, Alan, for giving me this honor. And I want to really thank Alan and Jeff for organizing this wonderful event. It's very informative and very beneficial. Thank you so much. And also I want to thank all the panelists for joining this session. Your advice and suggestions, opportunities are great for our students. Chan, we've known each other for a long time. Thank you so much for staying connected with us and for continuing supporting us. Fabiola and Surit, the advice, the opportunities you shared, they're all great. And especially Fabiola, I wanted to follow up with you. I'm in University of Houston, so we're neighbors. I think what you shared can also be great and very beneficial for UH students. So I definitely want to follow up with you for future events at the University of Houston. And students, thank you all for joining us today. QSR is a great platform community. We organize events all year long, and this is a great place for you to make friends, to develop collaborations, and connect with industry and academic professionals and grow yourself. So if you have not joined QSR, please consider joining us. Thank you all for attending today's session.
All right, so thank you everyone for attending. Thank you very much for your participation, for your sharing your experiences. And so here we conclude the session. Thank you very much.
Thank you.
Bye-bye.